Hello everyone, welcome back to Coding Charms. This video is video 4 of our sliding window pattern series. In this video, we are going to be solving the problem minimum size subarray sum. So far, we have solved the problems with constant length window. This video is with variable size window. So let us start by reading the problem statement. Given an array of positive integer numbers and a positive integer target, return the minimum length of subarray whose sum is greater than or equal to target. If there is no such subarray, return 0 instead. So firstly, we are given with the target sum 7 and we are given the numbers. If you consider all the combinations of the subarrays and their sums, 4, 3 gives you the minimal length with the given target. So we return 2. And here again, we have target 4 and given with this array. And you can see we have the element 4 here, which is equal to 4. So we can return the subarray length as 1. And here we are given with target 11, but we don't have enough sum in our array, entire array. So we return 0. So this is the problem. In previous cases, we were given with some k value or the subarray length, and we were asked to find something in the subarray. Either it is the sum or the average. But in this case, we were asked to find the length of the subarray itself. So let's consider this example. In this example, we have taken the array 2, 3, 1, 2, 4, 3 and the target value as 7. And we have to find the minimum length subarray with sum greater than or equal to 7. So let us first write down the numbers 2, 3, 1, 2, 4 and 3. What will be the brute force or naive approach of solving the problem? In brute force approach, what we can do, we can get all the subarrays and then we can calculate the sum of all the possible subarrays and we can check if the sum is greater than or equal to 7. If it's greater than or equal to 7, we take the subarray's length and we take minimum of them and we return it. So let us see. We start at 2. We take all the possible subarrays from 2. So firstly it will be 2 itself. 2 and 3, 2, 3, 1, 2, 3, 1, 2, 2, 3, 1, 2, 4, and finally 2, 3, 1, 2, 4, 3. So this subarray sum will be 2. This subarray sum will be 2 plus 3, 5, and 5 plus 1, 6, 6 plus 2, 8, 8 plus 4, 12, and 12 plus 3, 15. So here if we check, this is less than 7, so we don't consider it. Less than 7, we don't consider. Less than 7, we don't consider. Here 8 is greater than or equal to 7 and minimum is, we haven't taken any minimum. So the minimum will be now 4. This is greater than 7 as well. The length is 5. But since the minimum is 4, we do not consider this. And here also we have greater than 7. But the length is 6. We do not consider this as our minimum is 4. This is minimum length. Now again, what we do now, let me erase this, and now we go to 3. We move by 1 position and now we consider all the subarrays starting at 3. So first it will be 3, 3, 1, 3, 1, 2, 3, 1, 2, 4, 3, 1, 2, 4, 3. Here the sums will be 3, 3 plus 1, 4, 4 plus 2, 6, 6 plus 4, 10, and finally 13. This is less than 7. And this is less than 7 as well, less than 7. 10 is greater than or equal to 7. What is the length? Length is 4. Minimum length also 4, so we don't consider it. And here 13 is greater than or equal to 7. And the length is 5. We don't consider this as well. So we do this for every other number until the end of the array. We do it for all the subarrays. We consider all the subarrays and take the sums and then take the lengths if they are greater than or equal to 4, and then we finally we consider the minimum length. What will be the time complexity of this approach? The time complexity will be O of n into n to generate all the subarrays, and another n complexity to calculate the sum of the numbers present in the subarray. So total it will be O of n cube solution. Can we optimize this? Let's see how we can use the variable length sliding window to optimize this. So firstly, we have our numbers 2, 3, 1 and 2, 4, 3. In variable length sliding window problems, we usually have two pointers S and E, start and end, to represent the starting and ending of the sliding windows, and using them we can know what are all the elements present in our window and also calculate the length of the window. So in this problem, we keep two variables, current sum, which is initially 0, and minimum length, which keep tracks of the minimum length sliding window with target greater than, with sum greater than or equal to target. So it will initially be infinity. In this, we have two cases. If our current sum is less than target, then we expand our window. We expand the window. How do we expand the window? By adding the array of end to the current sum. So to current sum, we add array of end. And if current sum is greater than or equal to target, then we shrink the window. To shrink the window, we perform current sum minus equal to array of start. The things will get more clear when we start the execution. So here basically we have two cases. This is one case and this is another case. So let's start the execution. Currently, so firstly, the current sum is initialized to 0. And firstly, we are at 0th index. Let me write down the indexes as well. So these are the indexes. And we are at 0th position. So we add the sum, we add the value to our current sum. So current sum is 0, 0 plus 2 will be 2. Our current sum will be 2 now. 2 is less than 7. So we keep expanding our window. To expand our window, we move the E pointer forward and we again add the value to our current sum, 2 plus 3. Our current sum will become 5. We update the current sum to 5. 5 is still less than 7. So we keep expanding the window. Now our ending pointer is at second position. So we add the value to our current sum. So 5 plus 1, 6. 6 less than 7. The current sum is still less than 7. So we keep expanding our window. We move this by one step. And now we are at third position. Ending is at third position. So we add it to our current sum. 6 plus 2 becomes 8. So we updated 6 and now it became 8. 8 is greater than or equal to 7. Now we have found a potential answer window. So this window has sum greater than or equal to 7. So this is a potential answer window. What is the length? We can calculate length using the formula E minus S plus 1. So what is E? E is 3, S is 0 plus 1. The length of the window is 4. So we update our these are the variables. So we update our minimum length, which is previously infinity, to 4. So let me make room. The current sum is 8 and length is 4. Okay, let's delete all of this. So current sum is now 8 and minimum length is 4. So now current sum 8 is greater than or equal to 7. Now what we do? Now it's the second case. We shrink the window. We shrink the window by moving the starting pointer forward. So let's move the start pointer forward. By moving the starting pointer forward, what we did? We removed the 2 value from our window. So we subtract the value from our current sum. So current sum is 8. We remove 2. 8 minus 2 will become 6. So we now this makes sense, right? Current sum minus equal to start. Then we do start plus plus if we want to shrink. So now our current sum is updated to 6. 6 is less than 7. Now again what we have to do? We have to expand our window. So we move our end pointer one step forward and our end pointer is at 4th position. So we add the value less 4 and we get current sum 10, and 10 is greater than or equal to 7. So we update the current sum. Current sum is now 10 and it's greater than or equal to 7. So this window is a potential answer window. What is the length of the window? 4 minus 1 plus 1, 4. So the length of the window is 4, but our minimum length is also 4. So we don't update the minimum length. We keep on searching for the window which has a minimum length less than 4. And now our current sum is 10. So we have to shrink the window since 10 is greater than or equal to our target. So we shrink the window by moving S pointer one step forward. So we have to subtract 3. So we do that. 10 minus 3 equal to 7. 7 is still greater than or equal to 7. So this window is a potential answer window. So now what we do, we calculate E minus S plus 1. We calculate the length of the window. The length of the window is 4 minus 2 plus 1. It's 3. So now the length of the window is 3 and the minimum length is 4. So we update the minimum length with the current window size, which is 3. So now what we do, now is the current sum is 7. Current sum is 7. So the current sum is greater than or equal to 7. So now again we try to shrink the window. We move the S pointer over here. And now the current window sum will be 7 minus 1 equal to 6. 6 is less than or equal to 6 is less than 7. So we try to expand the window. And we here expand the window. E goes here. And now we have to add it to our current sum. 6 plus 3. 6 plus 3 is 9. 9 is greater than or equal to 7. We update it. This will be 9. And now 9 is this window is a potential answer since 9 is greater than or equal to our target sum. So what is the window size? E minus S plus 1. The window size or length is 3. 5 minus 3 plus 1 is 3. So here we minimum length is also 3. So we do not update it. We try to look for the window which is less than 3. Now our length is 9. 9 is greater than or equal to 7. So we try to shrink the window. So let us remove this and move S pointer one step forward. So now we remove 2 from our current window. 9 minus 2 equal to 7. So 7 is greater than or equal to 7, but this is a potential answer window. So now we calculate the length of the window. E minus S plus 1, 5 minus 4 plus 1 equal to 2. So we update the minimum length by 2. The current sum is 7. So our minimum window is 2, and now the current sum is 7. So 7 is greater than or equal to 7. So we try to shrink the window. The S moves to, let me remove this. The S pointer also goes over here. And now we remove or subtract this value, 4 value from 7. Now it becomes 3. So 3 is less than or equal to 7. Now we try to expand the window, but there is we are at end of the array. There is nothing to move forward. So we stop the execution here. So let us now we take what is the minimum length? Minimum length finally is 2. So we return 2. The array is 4, 3. So this is the minimum length array, and minimum length is 2 with target with the sum greater than or equal to target. So what is the time complexity of this approach? Here we have taken 2 pointers S and E. Each of them have moved through the array once. So O of n plus n, O of 2n. O of 2n is equal to O of n only. And what is the space complexity of this approach? The space complexity is we have used only constant variables. We haven't used any external space, auxiliary space. So the space complexity will be O of 1. The time complexity is O of n, the space complexity is O of 1. So let's code it up. So let's start by calculating the length of the array, given array. So int n equal to numbers of length, and for we have to initialize the start pointer, it will be 0, and we also have to have current sum, which will represent the current window sum, it will be 0, and we also should have minimum length, which represents the length of the minimum window with sum greater than or equal to target. So initially it will be integer dot max value, and we have the end pointer, int end pointer, which runs from 0 to n and plus plus. So firstly we expand the window, so current sum plus equal to numbers of end. Now what we do, we check while current sum is greater than or equal to target. If current sum is greater than or equal to target, this can be of a potential answer. So we calculate its length and check with the minimum value. So minimum length equal to min math dot min of min length comma current window's length, that will be n minus start plus 1. And now we shrink the window. To shrink the window, we do current sum minus equal to numbers of start, and then we move start pointer forward. Finally, we have to check here if there is a subarray with the current sum equal to target. How to do that? We can check if minimum length is equal to integer dot max value. If it's still integer dot max value, then we haven't found any such array, so we return 0. And if minimum length is not integer dot max value, then we have found some array, so we return that minimum length. So let us run the code. It got passed for the sample test cases. Let us submit it. It got accepted. So as discussed, what will be the time complexity of this approach? Time complexity will be O of n, and space complexity will be O of 1. Since we are not using any data structure, we are only using the constant variables. So I hope you understood the problem. If you did, make sure you hit that like button. And I hope you are liking the series. Do subscribe to Coding Champs YouTube channel for more such useful content, and keep practicing. Take care. Bye bye.